Welcome to the class. Myself Ashwini, and this is our class is about mode. In analysis of univariate data, we are going to how to calculate the mode that we are going to see in this class. And mode is nothing but, the definition of mode is the maximum number of times a data will appear. Mode is nothing but a maximum number of times a data or a value will appear. That is our mode value. And in this mode also we have three types of data. We are going to calculate the mode for three types of data. One is ungrouped data, discrete case, and a continuous case. And today's class we will see how to find the mode value. Find mode for the following data. So this, we know that this is ungrouped data. This data is ungrouped. Since this is an ungrouped data and mode is nothing but a maximum number of times a value will appear. Maximum number of times a value will appear, or in data maximum number of times if the value is repeated value, we call it as mode. So in this data you just observe which value is repeating most of the time. Here 100 has repeated 1, 2, 3 times. 100 repeated only 3 times. And 120, 1, 2, 3, 4, 5 times. 120 repeated 5 times. And another value is 130. 130 repeated only 2 times. So that which value repeated most of the time? It is 120. 120 repeated 1, 2, 3, 4, 5 times. So 120 will be your mode. In the given data, 120 appears maximum number of times. That is 5 times. 1, 2, 3, 4, 5 times. Therefore, our Z is nothing but mode, and mode will be denoted by Z, and mode value is 120. Understand? The most of the time, the number of times if the data is repeated more, that maximum times, that we call it as a mode value in ungrouped data. And next is, for group data, we have to calculate mode. Calculate mode for the following data. X and F. We know that this is discrete data and this is a discrete data. Discrete data, or in group data it is a discrete type. Say in discrete data they have given the frequencies. Frequencies is nothing but the number of times the value is there or repeated anta artha. So that here frequency, we have to observe the frequencies first. In this frequency, if the maximum number we have to see, that is 20, and for 20 the X value is 25. We have to first we have to see the frequencies. In this frequency, the maximum number or a highest value we have to see, that is 20, and that corresponding value corresponding to this 20 frequency is 25 in X, and this 25 Z or a mode is 25. See here Z is the mode value of X. Here this is the value of X corresponding to the highest frequency. See here in this frequency the highest frequency is 20, corresponding to that this 20 value 25 is there, so this 25 is our mode value, and that 25 is our mode value. Next, see here this is a class interval or a continuous data. So this is a continuous data with class interval and the frequencies, and for this to find mode for the continuous data we have a formula to find a mode, that is Z is equal to L plus Fm minus F1 divided by 2Fm minus F1 minus F2 into C. Here this Fm is nothing but the modular class, the frequency of the modular. See here, first we have to see the highest frequency in this column. The highest frequency is 30. You just block this, and maximum frequency Fm, this is your Fm. Maximum frequency, this is your Fm, and the previous one before that it is F1 and this is F2. You just see this. We have to observe the maximum frequency in the frequency column. Here we have 30 is maximum. You just block that row, and that value, that maximum value is the maximum frequency 30, and before that frequency we call it as F1, above that it is F2. 30 ಗಿಂತ ಫಸ್ಟ್ ಇರೋ ವ್ಯಾಲ್ಯೂನ ಫ್ರೀಕ್ವೆನ್ಸಿ ವ್ಯಾಲ್ಯೂನ F1 ಅಂತ ತಗೋಬೇಕು, 30 ಆದ್ಮೇಲೆ ಇರೋ ವ್ಯಾಲ್ಯೂನ F2 ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಬೇಕು, ಅಂಡ್ ಯಾವ ಇಂಟರ್ವಲ್ನ ಬ್ಲಾಕ್ ಮಾಡಿರ್ತೀರಾ ದಟ್ ಇಂಟರ್ವಲ್ ವ್ಯಾಲ್ಯೂ frequency we call it as Fm. Now you substitute everything in the formula, and L is 3000. This is your L. Substitute the Z values. 3000 plus Fm is 30, 18, 2 into 30 minus 18 minus 17, and width of the class interval, the difference between the upper and lower limit, it is 1000. So this is 3000 plus, after simplification you will get 50 divided by 23. So this is 3000 plus 480. 3000 plus 480. So the last Z value is 3480, and this is your mode value. This is your mode value. Next problem. We will solve one more problem on class interval. We are going to solve one more problem on class interval. We have to calculate the mode. here in this class interval, the interval is not equal. Here this is 3 and this is 3, again it is 2, 3, 3, 2 like this, and at last it is 5, 5 each. So that I will make this class interval first as an equal width, so that our new class interval is, I will just add up the class intervals. Since this last 3 class intervals have the difference 5, so I will follow the same thing for this. So it will be 0 to 5, 5 to 10, 10 to 15, 15 to 20, 20 to 25, 25 to 30. And we will see the new frequency also. This is our new frequency. So this is for 0 to 3 it is 2. So the 0 to 5 means we have to have 0 to 5. So add these two and write here, and this class interval is 2 plus 5, and then 5 to 10, 5 to 10, that is 5 plus 5, it is 10. Next 10 to 15, 15 plus 5, it is 20. And next will be same, 7, 5, 3. For this, this and this it will be same. 0 to 5, 5 to 10, 10 to 15, 15 to 20, 15 to 20, so sorry, 5 plus 5 it is 10, then 10 to 15, 10 to 15 it is 20, 15 to 20 it is 7, then it is 5, 3, yes it is same. Now we have to see the maximum frequency or the highest frequency in frequency column, that is our 20 is the highest frequency. You just block that, and this is our L, and this is our FM, this is F1 and this is F2. Substitute the values. So Z is equal to 10 plus 20 minus 10 divided by 2 into 20 minus 10 minus 7 into 5. So Z is equal to 10 plus 2.17. So Z is equal to 12.17. First we have to we made the class interval equal width, then we have solved for the Z value or mode value. Next, we have a relationship between mean, median and mode, and that relation, using that relationship we can find any one of the missing values. Either it can be a mean, median or the mode, and that formula we call it as empirical formula, and now we are going to find using that empirical formula. This is our empirical formula, and our empirical formula is Z, that is mode is equal to 3 median minus 2 mean. This is our empirical formula. Using this formula we can find any one of the values. If the mode is not given, only mean and the median will be given, we can find the mode value. If the median is missing, using this mode and mean we can find the median. If mean is missing, using that mode and median we can find the mean value. So that there is a relationship between mean, median and a mode, and this relationship just they have given in this format, and this is called empirical formula. And now we are going to solve a problem on this. Here mean is equal to 23.19, median is equal to 23.33. Find mode value. So to find mode, I will take Z is equal to 3 median minus 2 mean. Median is 3 into 23.33 minus 2 into 23.19. You just simplify this so that you will get the mode value as 23.61. And next is, here they have given mean value. Mean is equal to 50.4. Mode they have given. mode is equal to 66.78 and median, find median. So we know that Z is equal to 3 median minus 2 mean. So Z they know that is mode, it is 66.78. Median we don't know, and mean value is 50.4. So I'll shift this to this side. 66.78 plus 100.8 is equal to 3 median. 3 median is equal to 167.58. Median is equal to 167.58 divided by 3. So median is 55.86. Similarly, we can find mean value also by simplifying this empirical formula. We can find the values, and in examination they will ask the empirical formula for 1 marks. They will ask like this, write a relationship between mean, median and a mode, and this is the relationship between, and one more relationship also we are having, that we will see later. For mean, median, mode, this is the relationship between this mean, median, mode values. So similarly we can find mean value also. In the exam they may ask this for 1 mark or this type of problem for 2 marks. Thank you.